It's a pleasure to be here with you and to tell you about something I've been dreaming about and working for many years. And now it's coming to the surface quite powerfully and quite usefully in many areas. I apologize for sometimes this flickers for some reason, but I hope it doesn't disturb the story. I'd like to give you a little touch of history, since I was there at the beginning of this journey, and give you a brief introduction to what we mean for fog computing. And then go quickly to 3 powerful application spaces for this technology, together with industrial internet. One is industrial automation. That's the focus of our activity as Nebbiolo Technologies. The other one is one of my favorite ones, and we'll get there, is the automotive that caught fire here in Silicon Valley in the last years, the autonomous car, the connected vehicle, and so on. And this is related to also intelligent transportation and smart cities. And then a little touch on what fog computing means for smart grid energy. But many, many other sectors will find the same usefulness, the same architectural dimensions of fog computing applicable. So this is the story, the day in 2010 when fog computing, the word, started here. This is the day 2010 at the Aquarium Research Center in Monterey, where I gave a talk about robots going down deep in the bottom of those big valleys under the ocean. And when I finished, the lady, Ginny, in the middle, approached me and told me, look, why don't you call what you're talking about fog computing? Because it's cloud computing brought too close to the ground. And I protested for about 15 minutes, and on the drive home, I thought, that's really a good name for what we are doing, what we have been doing in the last years. And I started trying it out and using it, and more I found good response. And so 7 years later, I'm still here talking about the same thing. What's happening is the edge of the network is always very important, but it was always very important in IT, it's still very important in IT, in mobile, in content distribution. But when IoT came to the surface, it became even more relevant to understand the need of resources, virtualized, real-time capable, secure, trusted, with storage, computing, and networking coming together at the edge. At the edge of the IT network, now they're calling this mobile edge. We are realizing that mobile can benefit from local resources at the edge, powerful, real-time capable resources, but also, and more importantly for what we are doing, in this space of operational technologies. This is the space at the other end, at the other side of the boundary between information technologies and operational technologies. And here is where we are living with fog computing these days. So what is fog computing? Fog computing is really the platform that brings modern, cloud-inspired computing. Storage here is important for our friends at Western Digital, and networking functions closer to the data-producing sources. In our case, machines, things, but not just bringing cloud down, is also bringing functions up from the machine world. The real-time, the safety functions, the trusting and reliability function required in that area. And this is a unified solution at the edge that really brings together communication, device management, data harvesting, analysis, and control. So this is kind of new, except for our friends in Wall Street. The real-time part was not as sensitive. Now we are realizing how important it is and how important the position of the resources is in the future of solutions in this space. And so it's not boxes, it's a distributed layer of resources, well managed at the edge of the network. And really has a lot of potential across multiple industries. Here we see the progress also in the awareness of this topic with the Open Fog Consortium that is now very active, and even the VCs. Peter Levine here is talking about the importance at the edge. What is really happening here is the convergence. All right, so this is to be understood. This is the convergence of IT functionality, the modern IT functionality with the OT requirements. And this is fundamentally the powerful angle that fog computing brings to IoT and machine world. So all the nice things that happen in the cloud come down but meet the requirements of resources, the needs, and the timing of the edge. And so when you look at what is brought into particularly the world of operations, you see these kind of functions that are not usually there. In fact, when you meet this operational world, you find microprocessors, you find Windows machines, industrial PCs, and so on. Not so much Linux, not so much the modern approaches to computing. These are the type of dimensions that you'll see have a particular impact on the pain points seen in the world of applications. So now we go to the use cases. So we have seen this picture of IoT multiple times, a lot of verticals. We are concentrating on these three. One is the industrial. The second one is the autonomous vehicle and intelligent transportation. The third one, just touched upon, is the smart grid. This is the area of activity for Nebbiolo Technologies. Those kind of body shops and industrial floors with large robots, with a lot of activity around those robots, with cells protecting the activities within each working space. This is the world of PLCs, industrial PCs controlling robots, very fragmented. Here we are really finding even more critical this boundary between operational and informational technologies. This is a firewall, also a mental firewall between the two worlds. And the best practice is very different in one place and the other, particularly also in the way we handle data, security, and many other areas. In this space, which is also a little more characterized here with this kind of machines that you see in this ISA 99 or ISA 95 type of picture, you see the boundary between the two spaces. And all right, so the key message here is very tough to go across. It's very complex, the interaction between the two worlds. And there is where deeply we find a number of pain points at the security level, at the hardware architecture level, at the data analytics and storage level, at the networking, software, technologies, and control architecture. There's a lot happening there that is old, 1980s time frame, very stable, but in need of new approaches. And this is where fog computing has a very strong impact. Now, this is, maybe you have to remember one picture of all this talk. Look at this. What is this? This is a graphical image of a body shop of an important car company. You see the dots represent computers, within boxes, industrial PCs, PLCs, controllers for welding machine tools, and so on. That is, if you sum up the numbers, is thousands of computers. Each one of them is updated through a UPC, USB stick, sorry, and is not managed remotely, is not secure because there's a trust that the whole area is enclosed through and protected through a firewall on the other side. But it's very stable, but very rigid. So this is the world that we are finding with dedicated, isolated, not secure computing. This is edge computing, but it's not what we hope to be seeing soon as fog computing in action there. So this is the situation. very delicate, very powerful, and very motivating. And now comes IoT. And this is not the solution. It's helping. IoT tries to connect this big region, for the operational region, to the back end, to the clouds, to the power of computing that is there, very important, predictive maintenance, many other things can be done from there. But it's still not solving the problem, because now you have to put little machines, gateways, into that region, one more machine to manage, one more machine to secure, and now you're taking the data out. You're not solving a lot of the pain points. There's some important benefits. This is very, very good, but it's not the story. The story is solved once you really go one step deeper. In fact, from connectivity between information technologies and operational technologies to really convergence. And you see it here where you're starting to replace those machines supporting each cell with a fog node, with a powerful convergent point of computing, real-time computing that can allow control and analytics and storage and networking in the same nodes. So now these nodes are starting to replace all the objects controlling a cell and offer more functions to the cell itself. And now you can imagine where this goes, to a convergent architecture, much more compact, much more homogeneous, much more like cloud brought down to the edge when this comes back. Okay, almost there. So this is, okay, this is now the image that you can imagine leads to this final picture. Now you're seeing the operational space with the fabric of computing, storage, and networking that is modern, that is virtualized, that supports an application store. Now you have containers there. You can imagine virtual machines and Dockers living in the operational space. At the same time, you have a continuum from the cloud to the network, to the modern network, moving to the edge into the operational space. This is where we are going, and this is where the world wants us to go. And the picture representing this transition and this application of fog computing in this area is the following. The triangle, the pyramid, is now showing a layer of modern computing that allows communications, analysis, control, application hosting, and orchestration in a new way. This is cataclysmic, really is a powerful shift, still not fully understood, but with immense consequences. And now you can do control tight, close to the machines, a little slower through the fog, and a little slower to the cloud. This is where we are going. And there's many, many use cases. I don't dwell on those, but we are proceeding with some of our partners exactly in this direction. Now the exciting topics, if I can have 5 more minutes making up the time wasted. What's going on here? The connected vehicle, the autonomous vehicle, the electrification of automobile are all converging. And I think it's very clear that the paradigm of fog computing is fundamental here. And in fact, imagine the equivalent of a manufacturing cell with the converging capabilities into the fog and compare it with what's going on with the autonomous vehicle. This is a picture we used at Cisco 7 years ago, but this is now. A car is a set of little control loops, ECUs, little dispersed, poorly connected computers. Very difficult to program, same as the manufacturing cell. And now, where are we going? We are going towards a fog node on wheels, a data center on wheels, but better a fog node on wheels with a much better network in between, with a convergence of the intelligence, the control, the analytics, the communications in the middle. And then a modern network, deterministic Ethernet, it's called TSN, is going to replace all these CAN buses and all these flaky things of the past. Same movement in industrial and in the automobile. And then you look at what's going on in the intelligent transportation. You can imagine fog computing at the edge, controlling the junctions, the traffic lights, the interaction with cars, cars to cars, and you see it here. This is the image, again, where you have the operational space of transportation connected to the clouds in a seamless way with these nodes of computing, storage, and networking at the junctions inside the cars talking to each other. So this is the beautiful movement coming to us, and it requires this distribution of resources with real-time capabilities. Here you see it, and now the smart grid. Again, it cannot continue to go the same way with a utility data center controlling everything one way. It has to have, and this is from Duke, and a standardization body. You can see that there's a need of intelligence in the middle, fog nodes, distributed computing, that are allowing local decisions. Energy coming from a microcell into the grid and out, a car that wants to sell its energy or buy energy doesn't need to go slowly to a utility data center to make decisions. So again, same architecture, same technologies needed. Very, very, very powerful. And we could go on and on and on. So what are we doing? We won't advertise here, but the name has to be remembered. The name comes from a grape that grows in the fog in northern Italy. It's in Piedmont. My hometown is behind that 13th century castle you see there. Out there is northern Italy, close to Switzerland. That vineyard is from my cousin. It's a good Nebbiolo, starting to be sold in California too. So this is the name. Nebbia Fog comes to Nebbiolo Technologies. We are building a platform for this space with all the features that we feel are required, and we are applying it to industrial automation. And our funders are not so much from here, are from Germany, Austria, KUKA Robotics, TT Tech, GITV from Japan. And a few bullets to complete my presentation. Fog computing is really happening. There's a deep need for this converged infrastructure for IoT, including fog, or edge as someone calls it. But we need to continue to learn, demonstrate, validate through pilots and POCs. And we need to continue to converge with each other and with the integrators, because these solutions are big and they are not from a little startup. They are from integrators, customers, big customers at the other end, and an ecosystem of creative companies. Nobody has all the pieces. No Cisco, no GE, and so on. In fact, they are all trying to create the ecosystem. And so let's play, let's enjoy the cloud, the fog, and the machines, and try to solve some of the big problems of this world.